Hi YouTubers. Once again, Dave out in Western Pennsylvania. I work with supercapacitors, and I just want to show you, I can pull this out of here. This is a membrane being prepared, a modified membrane being prepared of Agar Agar. Not agarose, Agar Agar. Soluble in near boiling water very quickly. And we pour, in a prior video, I showed you what it looks like. I leave it 24 hours at 20 degrees Celsius. Now, we'll be developing these for use. Here's another one. Okay. We're developing modified Agar Agar membranes of varying thickness and cross-linking with 25% mass volume chemical cross-linking agent glutaraldehyde, commercially available. And we dilute that down to 4 to 5% mass volume with distilled water. And we have these membranes soaking in the cross-linking agent solution, 24 hours in the lab here today. And that will give some mechanical toughness to the membranes. And after that, they'll be washed, and then they will be placed in saturated potassium chloride solution for 24, 48 hours so they can soak up the electrolyte. And from there, we will begin testing these with modified graphite felt electrodes. We'll be staying, of course, around 1.2 volts. We'll seal them up so the water doesn't evaporate. But just to show some people that want to prepare such membranes, we work with chitosan thin films and Agar Agar, two different applications. The chitosan, that we'll be using that with a phosphoric acid deep eutectic solvent. That'll be in another video. When I first started working with these materials, the YouTube videos can be very helpful because you're able to visualize, you're able to see what these things look like. In a scientific paper, many times, there's just a description of preparation and characterization. It's very important, particularly for home researchers and undergrads, to get a feel for what they're going to be doing. So we will then, after cross-linking, saturating with and without an electrolyte like potassium chloride, we'll dry them out very carefully with a food dehydrator and examine by scanning electron microscopy, SEM. So I'll keep you posted on what we're doing here. And what's interesting with the glutaraldehyde, the chemical reactions between the Agar Agar carbohydrate alcohol groups, OH groups, and the dialdehyde, glutaraldehyde, you're forming hemi-acetal and acetal linkages. They're reversible, and the important thing is the pH range. Now, this solution, when we first put it together, was about pH 3, the bath. So I brought that up to pH 6 using litmus paper, pH 6. And I think you want to stay pH 5 to 6.5. If you're too acidic or too alkaline, you're not going to get really too much cross-linking, I would imagine. But in any event, I hope this helps those that want to develop these. And they have other applications besides use in batteries and supercaps. Thanks for watching. Bye for now.